In this tutorial, we are going to talk about units. So this is the first tutorial sheet for physics 1015. So this is the first question, which is saying convert part A, microliter to cubic millimeter. Part B, 4.5 times 10 raised to the power 3 kgs per cubic meter to gram per cubic centimeter. Part C, 40.0 microliter to liter. Part D, 400 deciliter to liters. Part E, 0.04 mils to gallons. So let's start with part 1, which is part A. Okay, so they want us to convert microliter to millimeter cubic or cubic millimeter. So what is happening here is that what we have to understand is that 1 microliter is also equal to 1 cubic millimeter. So if maybe we have 3 microliter, this is going to be the same as what? 3 cubic millimeter. So in short, the ratio is 1 to 1. Okay, so maybe let's say they give us maybe 200 microliter. We want to convert this into cubic millimeter. So this is going to be 200 cubic millimeter. As simple as that. So for part A, it's just a matter of us saying 1 microliter is equal to 1 cubic millimeter. Okay, let's see part B. So part B, they want us to convert a 4.5 times 10 raised to the power 3. We have kgs per cubic centimeter. So we have to convert this to gram per cubic centimeter. Okay, so now what we have to understand is that we are going to use what we call dimension analysis. So dimension analysis is going to help us to convert 4.5 times 10 raised to the power 3 kgs per cubic meter to gram per cubic centimeter. So how can we use dimension analysis to convert this? So what we are going to do is we are going to write our 4.5 here times 10 raised to the power 3. We do know that when we say kg per cubic meter, it is the same as we say kg divided by what? This. Okay, so in short, there is a 4.5 times 10 to the power 3 kgs per 1 cubic meter. That is what it means. So now what we're going to do here is we are going to say we have a kg, then we divide it by what? Cubic this. So that is going to be 1 now. So we're going to say times. I'm going first to convert kgs. So what I'm going to do is I'm going to say in 1 kg, how many grams do we have? We've got 1000 grams. Okay, so in this case, as you can see, we are going to set the units in such a way that they should cancel each other. As you can see here now, kg and kg will cancel, meaning we are done now with kg. So we're going to say again times. Okay, so in 1 meter, in 1 cubic meter, how many centimeters do we have? So we're going to have is 100, but we're going to say 100, then we're going to say 100 to the power 3, because here it is also to the power 3. Okay, so this is going to be now in what? In centimeter cubic. Okay, so as we can see again, these they are going to cancel, these two are going to cancel. So it's just a matter of us now getting our calculator and find the answer. So we're going to have 4.5 exponent 3, which is times 10 to the power 3 times 1000, then this divided by 100 raised to the power 3, which is 4.5. Okay, so I'm getting a 4.5 gram per cubic centimeter. So this is the answer for part B. Okay, so let's go to part C. We see what we're going to get. So part C, they want us to convert a 40.0 microliter all the way to liter. So what we have to understand is that in one in 1 liter there is a 10 to the power 6 microliter. So for us to convert this one, we can use dimension analysis. We can say that 40.0 microliter times so in 1 liter, how many microliter do we have? We have got 10 raised to the power 6 microliter. So as we can see, microliter and microliter will cancel, so we're going to remain with 40 divided by 10 raised to the power 6, which is going to give us 4.0 times 10 raised to the power negative 6. Okay, this is now in what? In liters. So that is it for part C. Let's go to part D. Okay, so part D, we want to convert deciliter to liters. So what we have to understand is that in 1 liter there is 10 deciliters. Okay, so we have a 400.00 deciliter. We can use dimension analysis to convert deciliter to liters. So it's going to be, in 1 liter, how many deciliters do we have? Okay, we have got 10 deciliters. So what we're going to do now, deciliter and deciliter will cancel. Okay, so these two, they will cancel. We're going to remain with liters. So it's just a matter of us saying a 400 divided by a 10, which is going to give us it's going to give us a 40. So we're going to have 40 liters. So the answer for part D, converting 400 deciliters to liters, is going to give us a 40. Okay, let's go to part E. Okay, so part E, we want to convert milliliters, okay, to gallons. So we have 0.04, this all the way to gallons. So this is just basically gallon. Okay, this GL, it is gallon. So what we have to understand is that in 1 gallon there is 3,785.41 milliliters. Okay, there is 3,785.41 milliliters. Okay, so what we're going to have now is, since we want to convert this to there, we can use dimension analysis. We can say 0.04, okay, this we are going to say times, so we are going to say that we are going to set the units in such a way that they should cancel each other. So this is GL, which is gallon. So we're going to set the units in such a way that they should cancel each other. So we're going to put on top there, we're going to put GL, since we want to make, so we're going to say that in 1 GL, which is gallon, how many milliliters do we have? We have got a 3,785.41 this. So these, they are going to cancel, these two. Okay, so now we can see that what we're going to have is going to be 0.04 divided by 3,785.41. So this is going to give us 1.06 times 10 raised to the power negative 5 GL. Okay, so that is it for question 1. So here is our question 2. So question 2 is saying, suppose a hair grows at a rate of 0.79375 millimeters per day. Find the rate at which it grows in nanometers per second because the distance between atoms in a molecule is on the order of 0.1 nanometer. Your answer suggests how rapidly atoms are assembled in this protein synthesis. Okay. So now they want us to convert, in short, they just want us to convert 0.79375 millimeters per day to what? Nanometers per second. Okay. So we need to know how to convert nano. So maybe let's say we want to convert, we have got 1 meter. Let's say we have got 1 meter. So we want to convert to put it in what? Nanometer. Okay. So nano is 10 to the power 9. So in 1 meter, there is 10 to the power 9 nanometer. Cool. So we want now to convert, we are going to use dimension analysis to convert this. We want to convert 0.79375. It is millimeters per day. So I can just put a day here, which is just okay. Okay, now from there, what we're going to do is we have first to convert millimeters to meters. Why? I want us to come from meters, then nanometers. Okay, because I'm from telling you to say 1 meter is equal to 10 to the power 9 nanometers. So I want us first to come from millimeters to meters, and then we come from meters to nanometer, which is going to be better. So what we are going to do now from here, we are going to say in 1 meter, how many millimeters do we have? Okay, so we have got a 1000 millimeters. So as we can see from here, these two, they are going to cancel. Okay, the millimeters and millimeters, they are going to cancel. Now we have got meters, so we are going to say that in 1 meter, how many nanometers do we have? Okay, we have got 10 raised to the power 9 nanometer. So meters and meters will cancel, so we are done because we want our answer to be in nanometer. So now let's start dealing with what days. Okay, so in 1 day, how many seconds do we have? Okay, so in 1 day, how many seconds do we have? So we're going to put here to say in 1 day, how many seconds do we have? So you can just think of this. In 1 day, there's 24 hours. Okay, so if I do 24 times 60, which is minutes, at the same time times 60 to get the what? The seconds. So I'm going to say that 24 times 60, meaning I've converted this into minutes, 24 hours into minutes, from minutes again into seconds. So I'm going to do times 60 again. Okay, so it's giving me 86,400 seconds. Okay, so it's giving me 86,400 seconds, meaning that we have now cancelled the what? We'll cancel the meters. We'll also cancel the days. Okay, so we have remained with the nanometer on top and the seconds down. So we're going to start now saying 0.7937, then there's 5 times 10 raised to the power times 10 raised to the power 9. Okay, then the answer we're going to get, so we're going to say that this, we divide it by what? 86,400. So let's see what we're going to get. So we're supposed to get 9.187 nanometers per second. Okay, so we can do it. We are saying 0.79375, this times 1 exponent 9. Okay, then we divide this by, we also have a 1000 down here. Let's not forget, we have got this. So this is supposed to be times this again. So meaning that we are going to say divided by 86,000. We are going to have 86, then 4. We have 2 zeros there. Then we are going to add the 3 zeros again. 1, 2, 3. Okay, which is going to give us 9.187 nanometer per second. So this is the answer for part 2, question 2. Okay, so we have question 3, which is saying the traffic light turns green and the driver of a high performance car slams the accelerator to the floor. The accelerometer registers 22 meters per second squared. Convert this leading to kilometers per minute squared. Okay, so this is acceleration. We want to convert meters per second squared to kilometers per second squared. Okay, so what we are going to do, we are going to use still dimension analysis. We have a 22 meters divided by second square. So we have got 22 meters in each second, in 1 second. So we're going to say this times, okay, since we want to come from kilometers, from meters to kilometers, we're going to say that in 1 kilometer, how many meters do we have? We have got 1000 meters. Then from here, I can see that meters and meters will cancel. So again, I'm going to say that in 60 seconds, okay, so I'm going to say that in 1 minute squared, how many seconds do we have? We have got 60 seconds, but this 60 has to be squared. Okay, has to be squared. So we're going to say that this is going to be now second squared. So these are going to cancel. This and this, they will cancel. Therefore, we're going to remain with the minute down, then kilometers on top. So we're going to say that a 22 times 60. Now this 60 has to be squared. Then I divide it by 1000, which is going to give me 79.2 kilometers per minute squared. Okay, so this is the answer for question 3. Okay, so we have question 4 for this tutorial sheet. The question is saying an ampoule contains a solution of drug of 150 microgram per 2.5 mils. Convert this dose into gram per liter. So now what we have to understand here is this is the same as 150 microgram divided by 2.5 mils. Okay, so it is the same as we just say 150 divided by 2.5. Then we are going still to have microgram per mils. Okay, so now before we continue, if you want to access all the solutions for this tutorial sheet, just register with Transcended Institute. If you want to get in touch with Transcended Institute, you can just check out the description, the link down. You are going to see the numbers and the website. Then you'll be able to register. So now what I'm trying to say here is if we are trying to make this one to be simple, we have 150 microgram divided by 2.5 mils. So I can just say 150 divided by 2.5, which is going to give me a 60. So this is the same as just 60.0 microgram per mils. So we want to convert this 60 to what? Gram per liter. So we have a 60.0 microgram per what? Per mils. Okay, so this we are going to say using dimension analysis. We know that in 1 gram there is 10 raised to the power 6 microgram. At the same time, I want to convert milliliters to liters. So we know that in 1000 mils, we are going to find that there is 1 liter. Okay, so in 1 liter there is 1000 mils. So we are going to cancel the mils. We are going to cancel the microgram. Okay, so from there now we can get our calculator. We are going to find that it's going to be 60 times the 1000. Then we divide it by 1 raised to the power 6. So our answer is going to be 0.06 gram per liter. Okay, so that is going to be our dose. Our dose in gram per liter is going to be 0.06 gram per liter. Okay, so that is it for question 4. Okay, so we have question 5. We continue. So the question is saying the skin is the largest organ in the human body. For a human adult, the average area of the skin surface is about 1.80 square meter. How much squared foot is this area? Okay, so now what we have to understand here is that in 1 meter there is 3.281 feet. Okay, so now we want to convert 1.8 to feet now. So what we're going to do, we're going to use dimension analysis, where we're going to say 1.8, okay, 0.80, which is in square meters. Okay, which is in square meters. So we're going to say that in 1 meter, how many feet do we have? We have got 3.281, but it is squared, so we have to square this. Okay, so we're going to square this as well. So using our calculator, we're going to see that we're going to have 1.80, then we're going to say times 3.281. Now we have to square it. Okay, so this is giving me 19.3769 feet squared. So now what we're going to do now, we are going to round it off, because this is in 2 decimal places. So even our answer is supposed to be in 2 decimal places. So our final answer is going to be 19.38 feet squared. Yeah, so the answer for question 5 is just basically 19.38 feet squared. Okay. Okay, so we continue with we have question 6. So question 6 is saying if the density of carbon tetrachloride is 0.793 grams per milliliter or per mils, and the sample has a volume of 9.29 milliliters, what is the mass? Okay, so this mils is just basically volume, and then we have got the mass. So we need to find the mass. We have got the density, so we need to find the mass. So we know that density is mass divided by volume. So we have our density, we have our volume. So it's just a matter of us making mass as a subject of formula. So it's going to be the mass will be equal to the density times the volume. So our mass is the one we are trying to find. Our density is 0.793. Now this is in gram per watt per mils. So times the volume is 9.29 mils. So now the mils. Okay, so we're going to use the measure. So we're going to cancel this. So we can get our calculator and say what is 0.793 times 9.29. So this is giving me the mass of 7.367. Okay, so our mass is going to be 7.3667 grams. But what we have to remember is that this one is in three decimal places, so we're going to leave the mass in three decimal places as well. Okay, so our mass is going to be 7.366. So it's going to be 7 now. I'm going to put 7. Then I put what? Yes, I'm going to put 7 to round it off. So this is going to be grams. Okay, so that is the mass. Yeah, so that is the answer for question 6. Okay, so we have question 7. So our question 7 is saying table salt has a density of 2.16 gram per mils or per milliliter. If you use 2.00 mils on your food, how much is milligram? How much in milligram is that? Okay, so what we are going to do here is we need first to find the the mass. Now that mass is going to be in grams. We are going to convert that mass into what? Into milligrams. Okay, so we have the density. So we know that the formula for density is a mass divided by volume. Okay, so we have the density. We want to find the mass. So we are going to make mass as a subject of formula. It's going to be density times V. So the mass will be, the density is 2.16 times the volume is 2. Okay, so what will be my mass? So my mass is going to be 2.16 times 2, which is going to be 4.32. 4.32, that is going to be grams now. So we want to convert now 4.32 grams into what? Into milligrams. Okay, so converting this, we're going to use dimension analysis, where we're going to say a 4.32 grams, then in 1 gram, how many milligram do we have? We've got 1,000. Okay, okay, so now we have got 1,000 milligrams. So what we're going to do now is we're going to say that 3. So these gram and gram will cancel. Okay, so gram and gram will cancel. We're going to have 4.32 times 1,000. Okay, so this times 1,000, we are going to get a 4,320 milligram. Okay, so this was the mass which was used. Okay, so that is it for question 7. Okay, so we have question 8. So question 8 is saying what is the density in gram per mils of a substance that has got a mass of 0.987 kg and has a volume of 4.52 times 10 raised to the power 2 mils. Okay, so they want our density to be in grams per mils, and they have given us the mass to be in kg. So we have to convert this mass into gram. Then we use the density method to say density is equal to mass over volume. Then we find the density. Okay, so let's first convert the mass. So we have 0.987 kgs. We want to convert this one into grams. So we're going to use dimension analysis, where we are going to say in 1 kg, how many grams do we have? We have got a 1,000. So kg and kg will cancel. We're going to have 0.987 times a 1,000. So this is going to give us 987 grams. So that is going to be our mass now. So we know that density is equal to mass over volume. So our density will be equal to, the mass is 987 divided by the volume. So the volume is 4.52 times 10 raised to the power 2. Okay, so this is in gram and this is in mils. So now what will be our density now? So our density is going to be, we're going to have 987 divided by a 4.52 exponent 2, which is giving me 2.1836. 2.1836. Okay, so I can round it off because this is in three significant figures, or let me say three decimal places. So we need to leave our answer in the same. So our density will be 2.184. That will be now gram per this gram per mils. Okay, so that is our density. So that is it for question 8. Okay, so we have question 9. So question 9 is saying how many part A degrees Celsius are in 315 Kelvin, part B how many degree Faradays are in 30.0 degrees Celsius. Then part C, how many Kelvins are in negative 15.5 degrees Celsius. Okay, so part A, we are converting Kelvin into degrees Celsius. Okay, so when we want to convert, for example, if we want to get from degrees Celsius to Kelvin, we just simply say the Kelvin is going to be the degrees Celsius plus the 273. Okay, so this 273 is in Kelvin. So now since we have the Kelvin, we want to find degrees Celsius. So we are going to make this degrees Celsius the subject of formula. So what I'm going to do is I'm going to shift this 273 to the other side. So it's going to be the K minus 273 has to be equal to the degrees Celsius, the one we are trying to find. So the Kelvin we have, which is 315, okay, minus 273. This is going to be equal to the degrees Celsius. So if we say 315 minus 273, this is going to give us 42. So we're going to have a 42, okay, a 42 degrees Celsius. Now we can also convert this into Kelvin, where we are going to add a 273. Then we'll come back to what? To 315 Kelvin. Okay, so the answer for part A is simply 42 degrees Celsius. So let's do part B, where we want to convert 30 degrees Celsius into Faradays. Okay, so we have got the formula. If we want to convert the degrees into Faradays, what we have to do is we are going to say the degrees Celsius which you have times 9 divided by 5, then you have to add this by 32. So the answer we are going to get, that is going to be our Faradays. Okay, so we have the degrees already. We have a 30, okay, times 9 divided by 5. So this is going to be plus 32. Okay, it's going to be plus 32. Then this is going to give us what? The Faradays, the degrees Faradays. So we can get our calculator. We say 9 divided by 5, it is 1.8 times 30, which is going to give us 54. 54 plus 32 is giving me 86. So 30 degrees in Faradays is going to be 86 Faradays. Okay, now this is question 9. If you want to access the solutions for question 10, 11, 12, 13 up to 15, what you have to do is just register with us, then you'll be able to access the solutions. Okay, so part C, which is saying how many Kelvins are in negative 15.5 degrees Celsius. So we're going to use the same formula where we said the Kelvin is a degrees Celsius plus 273. Now they have given us the degrees Celsius already, so it's just a matter of us putting there. So it's going to be negative 15.5 degrees Celsius plus 273. So what are we going to get? We are going to have negative 15.5 then plus 273. Okay, so this is going to give me our Kelvin is going to be our our temperature in Kelvin now is going to be 257.5. Okay, Kelvin. So that is going to be the answer for part C. Okay, so that is it for this question.